Good morning, this is Mr. Hooper, your flight attendant speaking. Please fasten your seatbelts for all the awesome dreams we're chasing in the clouds. I got no idea what I'm talking about, but I can factor special cases, so I'm going to try and teach you how to do it. So, here we go, Unit 4, Notes 4. So, binomial two perfect squares being subtracted. What that is binomial. So, think of bicycle is 2. We have B. I don't like the blue. Let's try this again. Binomial is ax squared plus c. And it says being subtracted, so it should be minus c. What happens is ax squared and c are both square rooted. They're perfect squares. So the bx term is 0x, so like this green one, I didn't even write plus or minus 0x because you don't have to write it. So then what you're doing is you're actually doing, this is going to be like the square root of ax squared plus the square root of c, and then ax squared, square root, and the square root of c. So you're going to kind of fill in those parentheses by just taking the square root of the a and c value. And it also always says to check for GCF. So let's see what this looks like. Basically, 1 here, if you square root 1, you get 1. So I know I can square root this, square root this. Square root of n squared is n minus 5, n plus 5. Now remember, if you don't believe me, you can always check your answer by foiling or box method. Remember, n times n, we would add 1 plus 1, so 2. It'd be plus 5n. Outside, inside would be minus 5n. And then the last terms would be minus 25. These go to 0, so it has n squared minus 25. So these are the special cases where basically all you have to worry about is writing down the correct square root and seeing square roots. Square root of 36 is 6. Square root of x is going to be 6, so I can write 6x. Then for this plus subtraction, 1 of each, and then I know it's 7y and 7y. So this is all you have to do here. You could check that, obviously, but as a person who doesn't make mistakes, you won't either. So we can just keep flying through these. However, 48, I'm not really sure what the GCF is, unless we did 12. There's an A in both of them. So 12a, alright, that'd be 4a squared minus 1. We had earlier that square root of 4 is 2, so this would be 2a plus 1 and 2a minus 1. Remember, 1 has the square root of itself. So that one worked out kind of nicely. On this one, we just have to take out an x, so then I'd have 9x squared minus 4. This one's hard to read, but you'd square root both of those, you'd have 3x plus 2 and 3x minus 2. And that's where we would want to be. So I think what you need to see here is that the GCF, just because it's an x cubed or an a cubed, look to take an x or an a out of both of them. Alright, look for common multiples still, look for greatest common factors, always, so that you can reduce things. This one's set up nicely for us because I don't see much to do with this. I think it's 8g minus h. Alright, plus, so it's less confusing. hg minus h. This is what we've been doing the whole time. So you gotta check these every time. This one's kind of tricky. Alright, I'm going to divide it by y. So now I have y is negative 4y squared plus 9. Now, because I'm good at math, I should know that I can reorder that. Alright, so what I did is I took a 9 and wrote it out front, minus 4y squared. These two are the same thing. And the reason I want to do that is when I do that, it's pretty easy to see that a square root of 9 is 3 minus 2y, and 3 plus 2y. Alright. perfect squares still are square rootable, and you can still just make 1 minus, 1 plus, and you can do it. This is the key here. Knowing you can rewrite things as long as you're only reordering it on the same side of the equals. You can't just move things to the opposite side. You gotta know you can reorder them. It seems like I'm really flying here. So, perfect square trinomials. So, trinomial in which were first and last term are perfect. Factor form is factored twice. Square root of the first term and last term. Add if middle term is positive. Subtract if negative. Subtract if middle term is negative. So, what you want to look for is this is going to show you perfect squares, but if it's positive in the middle, then you got to add both of them. If it's negative in the middle, you subtract both of them. Here's what we're talking about. I know the square root of 144 is 12. I know the square root of n is n. So I can write n, I can write 12, n, and 12. Now, this is negative in the middle, so they both have to be minus. And then if I were to FOIL that back out, I'd have n squared minus 12n minus 12n plus 144. So if you did box method or FOIL, that's what you would get, and you would see when you combine that, you get negative 24n. So this checks out, and this is the correct answer. So it's just a special case. Look at this little guy in the middle. 12. Okay? So square root of 9, square root of 4 should be 3y minus 2. And 3y minus 2 again. Now, I would always check these, because some of them are going to be tricky on your quiz, because I know they are, because I wrote it. So then I'd have outside minus 6y minus 6y plus 4. So you got to make sure that you can get this minus 6y here to minus 12y. Right? That's not always going to be the case. Sometimes it's going to have to be a normal trinomial, but you've got to look and see how many terms are written. Right? The binomials, you could just do perfect squares, make 1 plus, 1 minus. For trinomials, you got to look. If it's subtraction in the middle, they're both minus. If it's positive in the middle, let's find an example of that. Here's one. They're both positive. Alright, now let's look at this. This one, all three of these are even. So I know 2. Do I know anything else? Nope, just 2. So now I'd have 2 and 9y squared minus 24y plus 16. This is great news for people like me and you. You should have saw here, 18 is not a perfect square root. So dividing that helped me out a lot here, because now I should be able to see that these two do have square roots. In fact, it's 3y. This is negative in the middle, so it's going to be minus 4. 3y minus 4. If you come across something on a multiple choice test or your final, and it's written like this, alright, we did this to you in Unit 3. You should know that these two happen to be the same thing. They're both going to result in the same trinomial. Going back over to 10, I see 2 again, and I'd have 2 times 25g plus 20 plus 4. Well, then that's going to be 2 times 5g plus 2, g squared, g, plus 2, 5g plus 2. 5 times 2 is 10, so I'm liking 10 plus 10 is going to be 20g. So I like how this one turned out as well. Make sure you're looking for the trinomial. Now there's another way to write that one too. Remember, I could always, maybe this is going to be the multiple choice on your final. It doesn't have this answer, but maybe it does have this answer. So you got to know those two things are the exact same. Relatively prime expressions. So these are the ones, some expressions have no way to be broken apart. These expressions are not factorable. Make sure you try all possible combinations. Still check for a GCF. So there's going to be problems where you just can't factor them. Nothing goes into both of them. We teach you this last because every single one up to this point has been factorable. You just weren't trying hard enough or you didn't have enough number sense to find it. Now we're going to show you there are some that don't work. So now look at this. This is 1. Okay. I would add 9 and 1. Well, 1 times 9, or 3 and 3. Well, if I add 3 and 3, that's 6. If I add 1 and 9, that's 10. Alright, that does not give me this 3 here. So this one would be relatively prime. Now let's go over here. This one, I can take a 5 out, because I like GCF. This is going to be x squared plus 2x plus 2. If I do my little x method, maybe I do 1 times 2 is 2, and I need 2. Right? Well, the only thing that multiplies together is 1 and 2, and that's going to add up to 3 or negative 1, so that's not going to work as well. So this number 12 is relatively prime. Then last but not least, we have this 4x minus x plus 7. Alright, so they have nothing in common. Okay, I probably would do the x still. I'd do 4 and 7, that'd be 28, and negative 1. Alright, I'd have 1 times 28, 2 times 14, 4 times 7. Right, and then all these add up to 11, 16, and 29. Since both of them are positive or both of them are negative, I see nothing that adds the negative 1. So right now you should see that these are 3 examples of relatively prime. You can write out relatively prime each time. And if I can't read your handwriting, it's wrong. So, do as I say, not as I do. Hey, that's it. Alright, so make sure that you understand these 3 special cases. It's going to make life easier. You shouldn't be guessing and checking. You should be looking for opportunities like this to get things done very easily. Thanks for listening.